Good morning and welcome to another learning session on the Aston Data Academy. This week, what we're going to do, and we're going to touch on a few things like union or union all. We'll explain that when we get to that. We're also going to touch on some basic string functions we can do on MySQL. And then we'll look at what we call the case statement. And then we would also look at what we call subqueries. And then I think the final thing we'll touch on would be common table expressions. Okay. So we would start with union. So basically, union or union or is a way of combining or stacking results on top of each other. Now, obviously, if you run these two queries, you will see them stacked on top of each other, even without union. But it would show them for my case, it's showing them it's created two different tables, but it's run both of them. But what union or helps us to do is in your one result, it will then give you this on top of this. Okay. And I will explain why it's important in the real world scenario or as a data analyst, why you would have to use it. But basically, to write a union statement, you start just like every other SQL statement we've been writing, which would then be, in this case, let's say select first name. Let's say last name. And we say, let's do it from the employee demographics, right? And then you then put the union keyword. Okay. And then you write your second select statement. So let's go select, again, first name. Select the first name, the last name from the employee demographics. And then you use union and you say select first name, last name, and then let's do it from employee salary. Okay. Now, once I run this, let's see what we get. So as you can see, it's giving us the first name and last name. But notice something. It's just almost the same as running only one select statement. And that's because of the data we are using or the database we're using. And I'll explain why union or union all is very important. Now, the second one is union all. Union removes duplicate. So what that means is when you remove duplicates, what it does is first name Leslie Knopp. Leslie Knopp also exists in the employee salary. But instead of showing another Leslie Knopp, because we're using only union, it will remove it. But if I put union all is more like saying I still want the duplicate included. That's depending on the kind of analysis you want to do. Now, once we run this, every of these results will then show. I'm sure you're thinking, why would I want to write a query like select all from first name, from employee demographics, and then select all from last name, employee salary, just to have them stacked upon each other, right? If you look at when we run with union, right now we've run with union all, and I was explaining that union all will always give you duplicate. So what that means is when it has run what is in employee demographics and it has run what is in employee salary table, if both name exist, you will still see it. So if you look at, we have Leslie Knopp here, and then we have Leslie Knopp here. We have Tom. Okay, Tom is not in the employee salary, so there's no Tom. But once there's a duplicate, you still see the duplicated. There's Tom here and there's Tom here. But if I remove the all from the union and then run it, you'll see that it removes all duplicates. Then they appear just once. Okay. Now, why do we have to use union, or why would we use union? Why am I learning how to use union? Some organizations have different kind of database with the same kind of information. So I'll give you an example. You can be working for a company that has lots of customers in different countries. So they will have a table like, for instance, Nigerian customers, Ghana customers, UK customers. These are different tables. Now, if you want to do an analysis and they say do an analysis, let me see, or just give me a report, let me see all our customers. You understand? One of the easiest way to do that is union. So instead of going in that kind of scenario, instead of going and writing select all from Nigerian customers, then carry it and put it in an Excel sheet and do select all from Ghana customers and put it in an Excel sheet. That's where union comes in. Do you understand what I'm saying? So now you say select all from Nigerian customers, select all from Ghana customers, union, select all from Ghanaian customers. When you run it, Nigerian customers will be on top and then Ghanaian customers will be below. And then now, depending on maybe what you're showing, right now we're doing first name, last name. You could probably have a country location and then you put country there and then they can see it. But then it will just be like it's from one single data, one single table, but it's not. Because when I run, if in this our instance, because I'm using union, it's removed those that are from the employee salary. Well, let's just assume that what we have in the employee salary, the new ones, the duplicates that will come are our Nigerian customers. So let's just say this Leslie Knopp is a Ghanaian customer, but this other Leslie Knopp from the employee salaries, let's say is the Ghana salary and Ghana customers table. Then you see Leslie Knopp. They'll probably not have the same name, but I want you to understand it. In this case, we will not have to use the all, but I'm just using the all to explain what it is. And then let's say there's a country location, then you'll be able to see Ghana, 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 and then Nigeria, Nigeria, Nigeria. But then it looks like it's coming from one table, but it's not. It's coming from 2 to 3 tables, but it's only that way because you're using union. But if you had run them individually like this without the union, whatever visualization tool will give it to you, like in 2 different results. And even in my case, it's giving me vertically. Even if it gives you horizontally, right, which it will give for some people, it's not going to continue in the same result. There will be like a bar here that differentiates it. Do you understand? And then if you're even trying to export, it doesn't export them as the same thing. And that's why you use union or union all, so that if you're picking things from different tables that have, and one of the key important things to note is when you're using the union or union all, they must have the same number, the same order, and the same data type. Do you understand what I'm saying? That's why I used the Ghana customer and Nigeria customer. It means they will have first name and last name in those different tables. So you can go and do something like select first name. So you can't do something like this, it will fail, right? So if I do something like select first name, and then age from employee demographics, right? And then I come and say union, because we have learned union, it means I can combine results from 2 tables into one. Then they need to match the whatever you're using, like the same number in terms of first name, last name must match first name and last name from the other table, from Nigeria customers to Ghana customers. So you can do something like give me first name and age, union, and then do select occupation from, let's say, employee salary. Right, this will give you an error. Let me clear this so that you can see the error. If you run this, it will give you an error, right? If you copy the error, and we put it here, just so you can see it, the use select statement have a different number of columns. Because here, I remember I must match. This must match with this must match with this. Okay, first name, somehow, let's say it matches with occupation. Age doesn't have something to, so you can't do 2, 1 or 3, 2. Do you understand what I'm saying? This must always match with this. The number of columns you put in here must match with the number of columns you put in here. Does that make sense? So you can't put 3 columns in the first select statement and then put 2 columns. You definitely get this error. And it's as clear as the use select statements have a different number of columns. So they always need to match. Okay. We quickly just go to what we call string functions. String functions are they're mostly used with data cleaning. And so we're just going to learn a few basic string functions, like the basic ones. We're going to learn upper, we're going to learn lower, we're going to learn length, concat, and we'll learn trim. So they can help you to clean your data. They can help you to format your data and modify the text. So if you remember when we're doing data cleaning in Excel, where we're moving things to be either uppercase, we're moving things to the left and all that bit, you can also do that on MySQL. So one of the first string functions we would use is what we call upper. And what this does is it converts all the names to uppercase. So if, for instance, we run this select all from employee demographics, just so you see, you can see Leslie and Knopp. And these names, it's only the first letter that is in uppercase. But let's just say we want when the result comes out for everything to be in uppercase. Probably you get a request and you've created a report and you just get an update. You know what? Let's make all the first names uppercase. Is visible, is bigger. I know that's kind of request. So this is how you would write it in MySQL. So again, you'll start with the select statement. And now you use what we call upper keyword. The upper keyword is a way of telling MySQL that, okay, whatever column I put in this bracket that is giving me, whatever value that is there, make all of them uppercase. So in this case, we will say first name, right? And then let's leave last name the way it is. And then let's say from employee demographics. Okay, now once we run this, you see, it will give you all Leslie as capital letter because you've told it that I want all my first names to all be uppercase. That's what upper does. Okay, I'm straightforward, nothing much complicated about it. And just like how we have everything to be uppercase, we can say we want everything to be lowercase. So I'll keep this line of query, and then I will do something like, in this case, lower, which is the opposite of upper, but we want our last names to be lower, right? And we say from employee demographics. Now, all our last names will be in lowercase. So that's what upper and the lower string function does. Okay. We probably won't use it much, but probably there'll be an instance where in the report you're creating or whatever analysis for one funny reason, people want to see everything in uppercase and lowercase. So you just remember that we have an upper string function and we have a lower string function to be able to achieve that. Okay, if you quickly run that and you're successful, we can then move on to the next string function, which is length. And just like the name, length means we are counting the number of characters in each column or in each column you want to count for. This also, you'd probably not use it often. There'll probably come a time maybe they want to know, or you want to know in your own kind of analysis. I mean, this first name, how many characters does it have? Like I said, not very often, but probably there'll be a time that'll come and for the columns, you want to know the number of characters they have. So again, I'm going to do it from scratch. To be able to use the length statement, they work the same way. All string functions work the same way with every other function. You start with a select statement and do not all, we want to do length. So let's say you give it the first column. So let's say first name. So you're saying, give me all the first name first, right? Before we then do the string function. So you say length, right? And then what are we using the string function for? We always give you the brackets, but it says for the first name. So you're saying, give me every first name or give me the length of characters for those first names that appear, right? And let's do this from the employee demographics. So if we run this, we'll get a first name column and then we'll get their corresponding length, the number of characters each first name has. So it tells you Leslie has 3, 6, I'm sorry, Tom has 3, April has 5. So there's some bit of analysis you'll do, probably not with first name, could be probably with anything, probably with country. Just want to know how many characters each country has or how many characters each people's surnames have, this kind of stuff. If you want to count the number of characters in a particular column, you use the length. The next string function we would work on is what we call CONCAT. CONCAT is used when you want to join two things together, right? So more like we have the first name and we have the last name. They are different, but we then want to have a column called full name, for instance. And then it's just a combination of the first name and the last name. So the string function you will use is what we call concat. It's written as CONCAT, right? So to do that, again, you start with writing your select statement. So you say select, then you use the string function you want, in this case, which is concat, right? You select it. What are we concating? Like, what are the stuff we're concating? Exactly how you want them to appear in the column. So you're saying we are joining the first name column. You put a comma. Obviously, you want it to be neat. You want it to be very visible. So we put a space. To put a space in SQL, use what we call this apostrophe, right? So basically what you're telling SQL in this case is the two things I want to join are first name and last name, but obviously I wanted a space to be in between. That's why we're putting this apostrophe. And then what's the other thing we want to join? It is the last name. Okay. Then you can then call it, remember we talked about alias in previous class as what? We can call it full name. So you can do it like this, full name. SQL will understand it and give you the concatenation of both. But just basically telling SQL to give you a combine of first name and last name. And then this one just basically means make it a space. But to make it cleaner, you can do something like this. So you put this and you write full name. So instead of it appearing with the full underscore name, if you're creating a report so that it looks neater, you write it as an actual word, and then it shows this way instead of the full underscore name. We would go to what we call trim. I think if you remember, we did trim when we're doing Excel, and it basically just it removes spacing. Now from our results, both from our tables and columns, I don't think we have most of our the values of our columns are clean. However, we can still just write one so that you understand how it works. But just like every other function, when you write the string function, based on what you want to do, it then tells you, it gives you the option. So you're basically just telling it whatever column you put in the bracket. So in this name, if we say first name, in other words, we are saying if there are any spaces in the front or the end, just remove them. But like I said, in our result, we do not have whatever, and if they do, they will be taken away. So they are trimmed and nicely put. Like I said, most of the string functions are for data cleaning. You know, you've written your query and you feel like, oh, some of the names, there's a space in between. Let's say this Tom now, that it starts from somewhere here. You just use trim and all those ones just move and align to the left. And if there are spaces at the end too, it pushes everything. So everything starts from the left end. You're able to have a clean data. The next bit we are going to do is what we call case statements. So we're going a bit higher into the intermediate level of SQL. And a case statement is basically you use it to create new values based on conditions. So if you go back to when we were learning Excel, we used what we call the ifs and the if statement. If is this, do that. If is that, then do this, right? That's the same thing when we say a case statement in SQL. You use it to create new values based on conditions. So with case statement, you're like adding a logic to your data. And just like I've explained, so you think of it like, if is this, do that. If is this, do something else. To do that in SQL is what we call the case statement. So you say you do something like case, when is this, then this. So how do you write a case statement? You start by your select statement first. And then you can say select, let's do something like select first name. And let's do something like age, right? So that we can do a case statement in the age. Put your comma, let's just go under another line so that it's cleaner and you can see how the case statement works. So immediately I begin to write case. You can write it fully, it's just 4-letter word. Or you can select it from the option it gives you. You then begin to write what logic you want. But from the moment you write case, SQL begins to interpret it like, okay, you want to do a kind of if-else kind of statement. So, okay, you're saying something like case, then we start. These are the conditions I want for it in the case statement. So you say something like when the age column, remember we have an age column in the employee demographics, is less than 30. If you really understood the ifs, then whatever I'm doing here, you understand it properly. The only difference is we're using case instead of ifs like we do in Excel. But if you remember, when you write ifs, you put a comma, you select the column you want in Excel, and then you then put a comma and then put your double quote and write the value. If it meets the condition, it's the same thing. So you're saying when the value of the age in the age column is less than 30, then give them or let the results from what we will call it be, let's say something like they are young. right? Well, let's say we want another condition. You then put the when again. So you say when age. Then this introduces another, because I want to do the lowest, I want to do in between, and I also want to do above. So when we say the age, this introduces another keyword, what we call between. So it's between, let's say, 30 and 40. Then we call them, let's say, adults. Okay. Then if it doesn't meet any of these conditions, we can then say else they should be called senior, or whatever you want to put there. So this simply statement just means when the age is less than 30, if that person's age is less than 30, the new column we are creating, which we would call age group, let their age group be young. If the person's age is between 30 and 40, let the person's age group return as adult. If it's neither of those two, just give them senior, which means they are not less than 30. They are not between 30 and 40, which means they are from 40 and above, which means give them senior. Then you then do end. You use end here to say, or to give it that I've ended my condition, right? And then say, let's name it age group. You can either do it like this, end as age group, or if you don't want, which we can correct this later to make it neater, but I just want us to see how the case statement works. And then we are doing this from, let's do this from the employee demographics, right? Let me move this down. So once we run this, let me move this down so we see our results clearly. Let me clear this. So once we run this, we'll get our first name, we'll get their age, and we'll get their age group, right? So you can see Leslie is 44, and then the age group is given is senior, because Leslie is between 30 and is 44. Leslie is not less than 30. Leslie is also not between 30 and 40, so it gives it senior. If you pick Tom, Tom is 36 an adult. So Tom is between 30 and 40. So the case statement is more like what we do in if statements. We categorize or do some kind of grouping or condition and then give it a value, right? So you can get some form of request or query at work that, okay, or maybe you even want to do some visualization, but you don't want to do it. If you're doing a visualization, you can't do it based on individual age, right? So if you want to do categories or employees by age, right? If you remember, when we're doing our pivot table, and we'll do this in Power BI, is you can't create a visual without the age group. It makes it cumbersome. So you just have each individual bars for Leslie, Tom, and April. That's not what you want. If you want a very nice kind of visual, you have to do something we call the age group. So you say young. So you in your visual, you have something like employees by age group. And then in your visualization, young would have 1, and then adult will have 5, depending on the visual bar you're using, if you're using a bar chart and all that. And then senior will have 2, okay? But if you do not create the age group and you just try to create a visualization with just first name and age, you can see that most of them are individual, how do I call it? Individual ages. So you just have lots of age, which won't tell the story. It's not a very good analytical skill. So which means you then have to group ages, or it could be in other tables. It could be like countries, and you're grouping them by continents. You get what I'm saying? So you say when country is this, give it this continent. But basically, that's what the case statement does. It helps you to group things and put them into various values. So let's try a different example. So let's say we want to do something like let's say we want to do something like, okay, salary from the employee salary, and we want to do, okay, let's give people in the kind of salary they earn, high, medium, or low, right? So let's clear this. I think I'll leave it up to first name. So we can say select first name, and then we can say select salary. Put a comma, and again, so we say select first name, salary, and then we use our case statement. Case means we're telling us SQL, this is what I want to do. I want to do some conditioning. And then let's say when the salary is greater equals to 70,000, right? Then this person should be called high salary earner. If you remember, we did all this in Excel, right? And I told you most of the things you do in Excel, you can do in SQL. And one of the best ways is to master SQL. Because for most organizations now, as a data analyst, is you have to have the ability to pull information from the database, clean them, and then visualize them. And I did explain that, except maybe the organization is backward. In other words, they haven't advanced to using some of this advanced visualization. Only then would you be doing most of this, the ifs and whatever in Excel. But top organizations allow their data analysts to do all the messy stuff in SQL like this, so that once you're visualizing, it's just clear. So it's good to have both skills, but depending on the organizations, you can either use Excel or SQL to perform the same function. So we are saying when salary is greater or equals to 70,000, then we say it's a high salary. And then you go again and say we want to add another condition, and say when salary is greater or equals to 50,000, then let's call them medium salary earner. And then we say if it's neither of those things, let's say they are low, else low salary earner. And then again, we tell it we've ended our condition, but we want to call this column. Let's call it salary level, right? Where are we doing it from? We're doing it from the employee salary. Okay. And so once we run this, right, it gives us their first name, gives us a salary, and then it groups them into whatever salary. That's what basically the case statement is all about. So how it does it checks the condition from up to the bottom. So it will check, is Leslie's salary greater or equals to 70,000? If it is, then okay, high salary. It goes to run. Is run salary greater than 70,000? Run salary is high salary earner. It moves to Tom. It checks, is Tom's salary greater than or equals to 70,000? Tom is 50,000. No. It then comes to the second one. Is Tom's salary greater or equals to 50,000? Yes, it is. Then it gives it medium salary. It moves to April. Checks, is April's salary greater or equals to 70,000? No. Is it greater or equals to 50,000? No. What is April? It's neither of these, which means it's lesser than these values. So that's a low salary earner. So that's how it works. If it checks the first condition and it meets it, it doesn't go on to check the rest. So that's how a case statement works. And again, just like I've explained, it's very important when you're visualizing. You can visualize based on salary. You want to visualize based on groups. That's where the case statement comes in. Okay. The next bit we will go on to is what we call the subqueries. Everything we are doing now was what we call queries, but then there's something we call subqueries. And just like the word implies, subqueries, it means it's like writing a query inside another query. Now, obviously, our database is not so huge, and so you might not see the importance, and that's why I'll do a bit of more explaining as to why you always need to use subqueries. You'll get to a point where you're writing queries and you're dealing with large data sets you're working for. You cannot be a data analyst and be working for a company like Amazon or Facebook. They have lots of tables and columns, and their customer information are a lot. What happens when you run a query? So in this case, when you run this statement, is what happens in the background that you do not see is, or if I go back to more than one line of query in this case, which is this, what happens is in the Aston Data Academy, what is going on is immediately you say select and you hit execute. Obviously, it's running fast in our case because ours is a very small database. And even in some organizations with high data set, probably within 10, 15 seconds, you've gotten your results. But then there'll be some queries you write that requires one or two different kind of logic. Now, how it runs is when you do this is, what happens is a signal is sent to the Aston Data Academy. He opens it, and then he checks the column. He looks for first name, and then he gets all this first name. Now, you can imagine you're working for an organization that has 1 million customers, right? So it will get all the first name of the 1 million customers or 100 million, 10 million customers. It will look for their salary. It will then do this calculation for each and every one of them. Obviously, most faster. It's not like how I'm talking about. This are splits milliseconds, right? And even at that, you still get your result within 30, 40 seconds for 1 million for this kind of query. But then there'll be queries you write which will be 100 lines long, because you're going to work on reports where you need first name, salary, the salary level, you need their occupation, you will need, and so you have lots of columns. You can have about 20 columns. Now, in such instances, it's whatever logic or condition you're running, it will be doing it for first name, last name, salary, whatever occupation. So if you go back to our Excel tutorial where we had lots of information, if you remember that sheet in Excel, you can have something like that. And every logic you're doing, SQL is doing it in the background to find the calculation, or whatever logic. So you've done logic for. So in this case, now we're doing for low salary. You can have another case statement for age. Do you get what I'm saying? You can have another case statement or something else to look for something else. It will continue to do all that for each individual. Now, if you do all of them in the select statement, it's what we call, it's not efficient. It's what we call, it's not effective, because it's going to do everything one after the other. And that's where subqueries come in. So what subquery does is, instead of doing a kind of logic or calculation individually, you can tie everything into one subquery, run the first main query or the first outer query, and then run the second query that the SQL has already gotten everything for you at once. So it will make sense once we do an example so you understand how it works. So basically, so let's do one simple subquery. So let's do something like select the first name. And then we know we're usually, this salary is usually their yearly salary. So let's do one quick calculation. So let's do something like salary, their yearly salary divided by 12 to get their monthly salary. And let's just name it monthly salary. Right. And then let's do it from the employee salary, because that's where their salaries are. Okay. Now we're going to use a where clause because we want to do some kind of filter, so I can use like a subquery so you see how it works. So we can do something like where, and then we're saying their salary, which is divided by 12, which is their monthly salary, right, should be greater. Then to do a subquery, you always have to put your subquery inside the main or the original query in a bracket, right? So you open the first bracket, then you write the subquery. So you always start with a select because it's a new query itself, right? But it works based on the original or the main query. So we can call this like the kind of the outer query or the subquery, right? So we'll do something like select average. We do another calculation. Let's just say average for the monthly salary. And then we do this from the employee salary. All right, so we close the bracket. So can you say we have two queries, right? We are not using a union or union all. We're doing what we call a subquery. Once you put a second query along with the main query and it's inside a bracket, that's what we call subqueries, right? And I did explain that it will become handy because this subquery here is already doing a calculation for everybody. Now, what would have happened, because our database is not large, so it wouldn't make any difference because we just have 10 people, is if you're doing the average, if probably we put it in the main select statements without a subquery, because you can then come and then put a comma here, like we've done in previous videos, so you can watch that and then look for the average salary. So you just put the average. You just basically do this and you put it here and you will still get the result. But obviously, if you're working with a large data set, you don't want to be doing the calculation for each individual person once. What this does is SQL at this point doesn't care about how will I call it, this format, check Leslie and do this, check Leslie and do this. No. Why does it? It just gives you the average salary for everybody. So just go and focus on only salary and then gives you the average salary. Now, once it gives you this, it then is able to give you the first name for people that meet the condition of greater than the average salary. It's just how it works behind the scene. And when you become a bit experienced, you will probably write most of your queries the easy way of writing them in the select statement. If you have a senior data analyst, it will show you that if you run this takes 1 minute. But when you put them in a subquery, or what we'll call common table expression, which is the next thing we'll learn after this, they run faster. So they will do the same thing, but just more for efficiency. Just take it like that. And then try to understand what happens in the background, which is what I've explained. If you put this, and one thing about subqueries is you can run them. Do you understand? You can run them individually. So if you run this itself, it will give you the average salary for everybody. Are you seeing what it's doing? So it doesn't care about the first name. And like I said, if you're working with a large data set, you would have multiple columns. Obviously, our tables are not much. It just focuses on the salary and gives you the average salary. And it stores this. So it will store this and then go on to check. I'm only now looking, so it has made the work easier. That's why it will be faster. I'm only now looking for people whose monthly salary is greater than what I have gotten from this calculation. Do you understand what I'm saying? If you leave this in the select statement, it will do this. If we open the employee's salary, it will check for first name, last name. It will go like this. So it does this first. It runs the first subquery. It doesn't care about any of the employee ID because that takes time. It stores this value. Now it goes to check which people have a salary greater than this value. And those are the only people it's interested in, right? And so when you run this now, you're only going to get people first name and salary of those that are above that value we saw, which is 4,700. And that's how we use subqueries. When you then begin to work on large functions and large queries, you would need to, simplify them so that they run faster and they're far more effective in getting your result when you're dealing with large database. Another example we can do something for, let's say we just want to see, we have this employee, this PACS department that shows department ID and department name. So let's say we want to see people who are inside the finance department using a kind of subquery. So we want to see people who are in the finance department. How we would write that is, I think we'll leave the first name and then we do something like department ID. And then we say from the employee salary. And then we can say where the department, let's do something like where we want the department to be only those in finance. Now we then write our subquery. And to do that, we put it in the bracket, as I've told you, to tell SQL that we're working on. And if we want to put in a new subquery, the subquery has to be in a bracket so that SQL interprets it like a subquery. So we do something like select and then start with a select statement and say department ID. So we're doing it from the PACS and department table. But we only want those where their department name is finance. We want to see those in the finance department. Then we close this to let SQL know that we've completed. Again, if we run the select statement, just like we do the sub, it will work because it's a query in itself, but we're just adding it to a main query to do some simplification. So it's giving us that the department, we are saying because we want the finance, and the finance department ID is 6. So it's only interested in finance, right? If you run this select all from packs and departments. From packs and departments, if you run this, we have more than one department. We have finance, we have library, healthcare, public works. But in this subquery, we've limited it to only finance. So what the subquery is doing for us is, instead of running and checking for anything, it's only interested in finance. So only interested in the finance department, which has a department ID. If you want, you can just put department name here, still the same thing, just so you see the department name. Right, but instead of checking for everything, it will only focus for those that have finance. That's why it will execute faster. And then if you run for this, it should only give you people whose department is finance. Hold on. So when you look at our results, it's telling us that only Ben is in the finance department. And you see it's giving us 1. So obviously, if you do this subquery, if you do it in the main select statement, which we can then do with a join. If you remember, I taught join last week, so you have to reference that video. What will happen is it's going to focus on everything. So it will be checking every table and be cross-checking how they match. That's an extra milliseconds. Not making the result of your query. And one thing you have to know is if you create an automated kind of reporting where the database refreshes probably every week or every month, so there are always new data. So the data set continues to be higher, it continues to increase, and all that bit. And it's also some form of saving costs, not really your business at this point, but when you get to that level, the longer your queries are running and in getting those kind of things, they take memory space, and somehow there's some kind of monetary value that goes out from it. Yeah. So that you work with the DevOps and they're able to see those things from the end. So yeah, besides the fact that you want your report to load faster, and also if someone opens your report and they need to wait for 5-10 minutes just to see the report for the day, you know how it can be frustrating. So everything you do as a professional and experienced data analyst is to ensure that your queries are very effective. They shouldn't take longer to load. And that's where subqueries come in. It just basically helps SQL to be able to, not go through the normal step of, oh, check this, check every row. I'm only interested in finance. Let's store it somewhere. The finance department ID is 6. Now just go look for people who have department ID of 6 and then give me their first name. It's different. It's a different process as to select without the subquery. Select the first name, department ID, and then put department name, and then you do your joins. That takes longer. For our database, probably not much because it's simple, but for huge organizations, it makes a difference. There's a difference between a query running in 45 seconds and a query running with 3-4 minutes. And I've already explained how that is important, cost effective, efficiency of loading your reports faster and all that. The last bit we have that we would look at before we end the day is what we call common table expressions. And the short form is also CTEs. It's also a far effective way of creating an efficient way of running your queries. Unlike the subqueries where it is with or within the select statement, you create it outside of the select statement. So it's almost the same thing like a subquery, but it's another query, but you don't put it inside the select statement. You put it outside, and it usually runs first. You put it on the top of whatever your main select statement will be, and then reference it in your main select statement. So let me give you an example. So with it, you would always start with something like what we call the width. Once you write this width, you're immediately telling SQL that I want to create a CTE. It's called common table expression. So let me write it here. which we call CTEs. So you hear it a lot because you would use more of CTEs because you work with lots of, and you can write more than one CTEs and reference them in the select statement. But you would work with more than one, you work with more than one CTEs, or you work with a whole bunch of tables and columns and logics. And because you want them to run faster, instead of writing everything in your select statements, you will store them in this temporal table expression, right? So you start with and basically what you're telling what you're telling SQL is this is a CTE I'm creating. And then you give it a name, right? So in this case, what I want us to do is almost what we did with the subquery. We are going to just get their average monthly salary, and we will then do a condition to say that check if their salary is higher than their average monthly salary. If the monthly salary is higher than their average salary, then they should be included in whatever result we want to see. Almost the same thing as a subquery, but in this case, we are using a CTE to handle it, and they both do the same thing. CTE is also then faster because it's not within the select statement, it's outside. So it runs that quickly, saves it, and then comes and runs your select statement. And because you're going to reference your CTE in your select statement, just does the same thing as I've explained in the subquery. So you say width and you give it a name. So we can name it average salary. Your CTEs always have a name. So we name it with average salary. So we are saying the name of our CTE, or the common table expression, is this average salary. Then you use the keyword as and the brackets to then create whatever logic you want. But basically what we want to do in this CTE is we just want to get the average salary for every employer, right? So you then start with the select statement. So select, then we use the average keyword so that it can get the average. And then we want the average salary. Right now, if you run everything from select or from employee salary, it's going to give you their yearly salary. This is their yearly salary, but I want their monthly salary. So I will do something like, it's the average of the monthly salary I want. So I would, to get their monthly salary, I'll divide their yearly salary by 12, right? And then we can name this a monthly salary. So we close this. We can call it the average monthly salary. And just say average monthly. And we are doing it from employee salary. Okay, and then we close the bracket. So we've created our first CTE. So basically what we're saying here in this CTE is, in our database, in the employee salary, just get the average monthly for all the employees. Don't worry about any other thing. There is a salary table. We've named the CTE average salary because we want to find the average salaries, the average monthly salary. In the select statement, you then put the logic you're doing, which is you're finding their salary, you divide it by 12 and get their average. So you divide the salary by 12. So salary divided by 12, what you get, you then the average gets it, and you store it somewhere. And then before you then come and write your main select statement. So in your main select statement, again, you do something like select their first name. And then we say their salary, that's their yearly salary, divided by 12. And we say we'll call it as their monthly salary. Right. What else do we need? We're doing this from the employee salary. Then we do something here in the where clause where we are filtering. And then we say where salary, that's their yearly salary, which is divided by 12, should be greater. Then we create this subquery, select average monthly from average underscore salary. So basically what we've done is we've created this CTE, we've stored it. So we're already getting our average monthly salary values in the CTE. But what we want to show their first name, we want to show their monthly salary, which we've done the calculation here. We're doing it from the employee salary, but then we're putting in logic. Now this is where we reference the CTE. So we are saying the salary should be divided by 12 because we need it to be monthly because we know what we are getting here is the yearly. Now, once we've gotten the monthly salary, we then reference the value here that is already stored in the CTE. Remember, we named it average salary, which is here. This is where we are referencing it. So you are saying check the average monthly from this average salary we've created here. If you remember, I've explained that with this, we get their salary divided by 12. So in this case, let me tell you what goes on behind the scene. Leslie Knopp is 75,000 yearly salary. 75,000 will be divided by 12. Whatever Leslie Knopp's salary is saved, which we would see when we run the result. Then we come here, we get the first name. It doesn't go through the process of going individually. What is interested in is from this average salary that we've created, the CTE, which monthly salary is greater than it. Those are the ones we want in the result. I'm not interested in anything else, right? So to run it, you select everything. And then once you run this, you're only going to get those people who are earning more than the monthly average salary. And you remember when we run it, it was around 4,000. So if we run this, for instance, just hold on. So if you run this, I've just moved this just so we can get the average monthly. So if you remember, we're doing it from the average salary. I just wanted us to see what it saved. So this is the average monthly salary for all the employees, which is 4,770. So to be included, your salary must be above this. That's what basically we are doing here. Let me just comment this out. So that's what this query is doing. So when you look at the results, all of these people's monthly salary is greater than the average, right? If you look at the previous videos, we've already done this, and I've just explained that one of the reasons why you use CTEs and subqueries is so it runs faster. What it just does is it focuses SQL on what's important. Select statement is almost like checking everything based on how I've explained it some minutes ago, but it just focuses on a few things. It focuses on the salary column, their average salary, and then check those who are above. This saves the average salary for everybody, right? It saves it somewhere. You won't see it when the background is saved somewhere. And this gets the average salary for employee, which is 4,000. And then immediately just looks for the people here that we've saved their salaries, right? The average monthly salary, which of them are greater than that 4,000 we saw, right? Return only those people instead of going through. So if we didn't use a common table expression and a subquery, it will just begin to go one after the other to find each and every one of those. That's slower. That's an extra additional seconds for your result to be populated. Everything you write inside your CTEs are just normal select statements, but they are effective because you focus on a column, right? When you want to use CTEs, as you can see, we're only just focusing on the salary column. Obviously, our database is small, and I've explained that if we're doing something like first name, occupation, all those plenty, the result will be lengthy. If you do not use CTEs, so for instance, if we run everything from employee demographics, which isn't much to be fair, but some tables have, this is 5, some can have 20 columns, or maybe you do some joins and you add from a different table and then you have 20 columns, but you don't use a CTE. What it does is it's going to be referencing everything line after the other. But what CTE does is because we focused on this average salary, which is in the employee salary, sorry, not employee demographics, this salary, it's not interested in the first name, last name, occupation. The anchor is the salary, right? The anchor is the salary. It does the whatever needed calculation it is, both here and here, finding the average salary for all employees. This finds the average salary for individuals and then compare to see which is greater. Only then does it then focus on their first name or any other columns. It's the reverse without the CTE. It starts with the first name, last name, check their salary, does the calculation, goes to the next one. It picks it based on the first name because you've not told it what to focus on. Then it'll come to run, check run, do the calculation. But with CTEs, it does the opposite. It does this, it just calculates the average monthly for everybody, gets it, comes here, calculates the average monthly for individual. Because you know when we run this without this, it gives you the 4,000. Am I missing something? Let me see what my error is. Okay. Let me put the bracket in front, sir. So you run this, it gives you the 4,700, stores it, then check for their individual average, which of them is greater than 7,000. Then only it's then interested in their first name or any column you might be interested in or that you've written. They're quite different. It doesn't seem like it, but when you run live queries, it does. I don't know if you understand what I'm saying. If someone can, just so I'm sure you understand what I'm saying, can someone just quickly tell me the difference in why we use subqueries or CTEs instead of running them, and what happens behind the scene in SQL?